Okay, so the next type of problem we need to tackle with the calculator is how to solve something numerically. It requires that you have some kind of understanding what that really means. So like numerically means that it's data driven. Technically, if I'm trying to solve something numerically, it means that I'm going to substitute in a bunch of values for x and see which ones work. Now that is very inefficient, especially if we're doing this by hand. We have this equation from up here, 5 times the absolute value of, so let me write that down here, 5 times the absolute value of x plus 4, and then what was it, minus 2 equals 3. So if I'm substituting in all that, obviously right now, based on what we just did in the last problem, we know what the answers are. But if I didn't know that, I would then substitute in however many values I could think of for x and see which one is true. And like I said before, it's incredibly inefficient. However, our graphing calculator helps us with that by substituting in a ton of values for us automatically. So this is why we need to learn how to do this, because a lot of times we can do it geometrically, or if we have the graphs and things like that, but sometimes that's not an option. Sometimes it's all data driven. We only have the data and we have to learn how to analyze the data. This is why you need to know this skill and tool on the graphing calculator as well. So if the way we're going to do this, there's multiple ways, but the easiest way is to treat it like a Calc 0 problem. So it's going to start the same way we did for the geometric. You have to tell us what you're putting in the graphing calculator. When we assess you, we will not know how you used the graphing calculator or if you used it accurately without you showing us what's actually going on in the calculator. And again, there are too many of you for us to sit next to you and watch you do this correctly. So therefore, you are going to have to tell us, okay, this is what we're putting in the calculator. I'm going to put y1 is equal to, and for me to treat it like a y0, or a Calc 0, you need to move everything to one side and compare it against 0. I'll explain later why that's really important, why this is the easiest way to do this, but for now, we're just gonna get it ready. P.S. We have this in the calculator already, so I'm just gonna leave it like this. Like that. This is what I'm putting in the calculator. I'm telling everyone who's reading my paper, okay, this is how I'm using the calculator. I'm going to move everything to one side. I can see that by writing this down on my piece of paper. And this is what I'm going to enter into my calculator. So let's do that first. Move to the camera here. Camera. Turn it on. Hopefully I still have it in here in y is equal to. Yes, it's still in there, and y is equal to was right here. We've entered it from the previous problem, so that means we're ready to go. Now, the table setting is kind of interesting. Like we have the graphing setting, that's how you look at a graph. The corresponding table that goes with it, do you see above it in blue, is right there. If I needed to change the window of my graph, I would change it right here. Above it is the table settings. I can change the table settings up here. That works like a window, but just for a table. And also here, if I want to look at how much increments I'm moving by and things like that, it's going to help me there. So the first thing I'm going to do is I'm going to go into table set just to make sure. There's a couple of settings. First of all, I need to make sure that both the independent and dependent variable is set to auto. If it's set to ask, go down and highlight using the arrow key. For example, I could set it to ask right now and it would be highlighted over there. But for our purposes right now, we need to set it to auto. Later on this year, I'm going to show you how to use the ask button. But right now, we're going to set it to auto. I don't know. Yes, technically we do know because we just did the problem, but if you were going to do a problem from fresh you hadn't seen before, technically we wouldn't know where the zeros are actually. So that means I'm going to go to table start and maybe start at, let's try at negative, let's say 10. This is where our graphically we would start. Now, to put in a negative 10, I don't use the minus symbol. I have to use the negative symbol down here. You see in parentheses is a negative, and type in at table start, negative 10. So I push this button, the negative sign, It's not a minus sign, but a negative, and then typed in 10 to overwrite what's there. This here, delta table, it means by how many, what are the increments I'm gonna go by. In other words, I'm gonna start at negative 10, and it's gonna go through each of the numbers, substitute in values for x, starting at negative 10 and going up by 1 or down by 1. I could change it to 0.1, then the next number it would do is negative 9.9, negative 9.8. It would go by increments of 0.1. And then I can look at a table. So the way to look at a table is that we need to have the blue button pushed. You see in blue it says table. So I pushed the second button and then graph. And here we have the table. And for us, what we're actually looking for is for y1 to equal 0. So here I'm gonna go, I can navigate up and down the table using the arrow key. I'm going, oh, if it's substituted in negative 15, this is what the y value would be. And I'm looking for the y value to equal 0 because I moved everything to the other side of the equal sign so that y1 would end up having to equal 0. So I'm gonna navigate down, and I can see the values here are growing, so I'm going in the wrong direction. So in that case, I'm gonna navigate downwards. Oh yeah, here we have it. There is when x is negative 5, y1 is 0. So I found one of the solutions. I know that it's an absolute value, so most likely, not all the time, but most likely it'll have a second solution. So I'm gonna keep looking. Oh yeah, oh, look, here is another one. So at negative 5, we have a solution where y is equal to 0. And at negative 3, we have a solution where y is equal to 0. Those two are my solutions for this. And we found that graphically, so we should know that, oh yeah, definitely the table is telling us the right thing. The reason why we use calc 0 instead of like a calc intersect, like letting y1 and y2 be two different functions, is because then I would look for two different, I'll show you in a minute, but then I would have to look for the two values to be equal to each other instead of being 0. And when I have something that's equal to 0, let's say it wasn't like this number wasn't very nice, I could look at the y values. If a y value changed from positive to a negative, I know it must have crossed 0 at some point in between a positive and a negative value. So if it wasn't a very nice number, like this one is an integer, which is kind of a nice number, it's easy to find. But if it wasn't very nice, I would then be able to say, okay, it's gonna have to be between negative 6 and negative 4, or if it happened between negative 7 and negative 6, I know that it's gonna be some decimal that's gonna create a 0 there. So I could look into the table, I could change the table setting and go by 0.1, for example, and maybe I would then be able to find it. So just to keep that in mind, this is why we use calc 0 method to start it, like we move everything to one side, because it's much easier to look for zeros, even if the 0 doesn't come up in the list. As long as we have a change in sign from positive to negative, you know that a 0 must have occurred in between those two values, those two x values. In this case, it happens to be nice. Now, how do we represent this on a piece of paper? All right, let me just get back to our paper here. Our requirements are that you put in, obviously you have to show where the solutions or how you found the solutions. I know that they happened at negative 5 and negative 3 because that's where I'm getting 0 for y. So those two rows have to be there. Our requirement is that you also show the row above it and below each of those solutions. If there happens to be many values in between the two solutions, you don't have to list all of those values. You literally just have to make sure, oh, negative 5 was one of them, and we got a 0, and then we have x and we have y in the table. Above that, we had a negative 6, and the y value was positive 5 there, and below it, it was negative 4, and it's negative 5. I'm going to circle where the solution happens. I can see I have the row above it and the row below it. Another solution happened at negative 3. It happens to share the same, the row below is going to be the row above the negative 3, so it happens to share the same thing. But if it didn't, we would do this. You would just say, oh, it's dot, dot. Let's say it happened at positive 3. Then I would have 3, 0 like this, and then do the row above and the row below and give the y values for that here and here. But in this case, it just happens to be nice. They're close enough to each other that we don't have to do that. So I'm just gonna put in the negative 3, 0, And then I have the row above it. I just need to represent the row below it, -2. Then again, you're showing us in the graphing calculator that you entered it correctly. And don't forget to write the solution. So x such that that belongs to, even if we asked you to do the same problem twice, like we've just done now, we still would expect you guys to write down the solution each time, because we're checking that you tell us what you put in the calculator, what the calculator tells you, what the important information is in what the calculator is telling you, and how to draw a conclusion from that information. Those are the things we're looking for.